Okay, we have here a nice integral from the MIT Integration Bee 2022 regular season number 8. We have the integral of x plus sine x over 1 plus cosine x dx. And what I want to do in this one is use the Weierstrass substitution. I thought it was an interesting case just because oftentimes we want to use the substitution on something with a denominator like this. We like to use it on trig functions. But I think it's unusual that right here we just have an x, but this is still going to work out okay. So to get started with it, we're going to want to do this kind of unusual substitution that's not very intuitive, right? Because we're making a substitution for tan x over 2, and we don't have any half angles and we don't have tangent. But it turns out this works out nicely a lot of times if you're adding trig functions in the denominator. And from this first step, you can derive a value for cosine, sine, take the derivative just by rearranging this. And we want the x value, so let's actually rearrange this. If I take arctan on both sides, you're going to have x over 2 equals arctan of t. So solving for x, we have x is going to be just 2 arctan of t. And if you're not familiar with any of these formulas or you want to know where these come from, I've done other videos deriving this, so I'll provide some links in the description if you want some more background on this. Okay, so now let's go ahead with our substitution, just using everything we have to the right. So for our x, we'll start with this right here, and we'll have 2 arctan of t. Sine of x, we'll use this over here, so we're going to have plus 2t, 1 plus t squared. It's going to be a little messy at first. We're going to have just 1. Cosine is going to be 1 minus t squared over 1 plus t squared. The reason these tend to clean up so nicely is the dx value, because you'll notice we'll take the 2 out front, and then we're going to have dt over 1 plus t squared. But when we multiply that in, we're going to get cancellation here. So like this is going to cancel with this. Although I shouldn't really cancel it right now as we still need to multiply it by the 1. So let's see what that looks like. So if we multiply that in here, we're going to have 1 plus t squared. Then this is going to cancel and leave 1 minus t squared. And then all this stuff in the numerator, I'll just kind of copy over. But then in the denominator, the t squareds are going to cancel. 1 plus 1 is 2. So what we can do is just take that and cancel with this 2 here. And so the whole denominator goes away. And we can take this and break it up into 2 integrals. So let's just clean this stuff up and see what we have. And now at this point, we basically just have 2 pretty easy integrals that we can do. I think let's focus on arctan. What we can do is use integration by parts on this, but I'm going to need a little space. Let me try to consolidate this because I wasted a lot of space over here. Okay, now for integration by parts on this thing right here, what I did was created a 1, because we only have one thing here, so we want 2 things for integration by parts, and then I'll integrate the 1 using the DI method over here. And then arctan is going to be easy to differentiate. This is going to be the same thing as 1 over 1 plus t squared, and then integral here, that's just going to be a t. So then we have part of the solution right here on the diagonal. We're going to have 2 arctan of t, but we have the 2 to distribute in, so we're going to have t arctan of t, but we have the 2 to distribute in, so we're going to have 2 t arctan of t. And then this stuff here, this is going to be an integral. Distributing in the 2, we're going to have minus 2 t 1 plus t squared. But it's exactly like this thing here. If I just copy this down, then this piece and this piece, these integrals are identical. Those cancel to 0. And so we're just left with 2t arctan of t, and we just need to back substitute in order to finish this off. Okay, now in order to finish it, we already have our value for t right here. For arctan of t, we can actually use this. If I just divide off 2 on both sides, we can write it like this. Arctan of t is going to be equal to x over 2. So we'll just plug everything in. We've got our 2 in front. This is going to be just tan x over 2. Arctan of t is this, x over 2 plus c, but the 2's are going to cancel. And so for my final solution, we just get x tan x over 2 plus c, and that's it. Okay, there you go. A nice example with the Weierstrass substitution. Thanks everyone for watching. Have a good day.